much on the backside. All right. Should be running now. So we're doing the debate on this part, which plane you start with and why. Okay, a couple people have opinions. A couple people are still asleep. It's really hard to attend class if you're asleep next to your phone. It's really hard to learn anything and actually get value, because when it comes to the practice exam, I can't take it for you. So there's that. Which plane do we start with and why? Good. So how you want to start with this is you want to start on that right plane. It'll become obvious why here in just a second. I'm going to go ahead and recreate this. And what I'm going to do is focus on, since you'll be able to see the buttons that are being clicked and all of those details. It did start 2 instances of SolidWorks. How bizarre. How bizarre. Nope. Now there's 1. Now there's 2. And then there were none. All right. So I'm going to do this. I'm going to do it with the active window. I'm going to close out of this one. All right, fine. Make a part. Yeah, I don't need 2 instances. You're doing all kinds of bizarre stuff here. So it's literally trying to run SolidWorks in 2 instances at the same time. 2 simultaneous instances. All right, there we go. That's much better. Stupid PC tricks. All right, so here we are in one single instance. I'm going to go ahead and recreate this part. I'm going to go into, I'll go ahead and record the session for how I would create this part, and that way you can see what some of the strategery is. But I basically don't need anything other than this drawing. I'll quickly comment on a couple notation details so that you are familiar with them, because reasons. So, of course, you have to be able to see them for it to matter. All right, we'll drop through the infinity mirror. Fun times had by all. All right, so a couple notation things quickly. Through to slot means it goes only through this top portion. So we have the slot thickness, we have the diameter, we have our variables. So A, very carefully being noted here, there's a 1.5 millimeter inset. A is a dimension they'll give you as a variable. B is another dimension they'll give you as a variable. So again, that's edge to edge for the entire rectangular solid. They give you some spacing. There's also a trap right here that students fall for all the time. There's a key piece of notation here. There are 2 of these with radius 20, meaning 2 of these channels with radius 20 and thickness 1.5 millimeters. So there's one here, there's one here. They have a separation interior of 12.5 millimeters, but that is to the inside edge. And then from the inside edge to the inside edge of the second one is 42 millimeter spacing. That's important for the center of mass to get it correct. That's one of the key aspects, but the biggest trip hole or the trip wire on this particular part is right here. So they give you center line 27 square pitch for the center line of the hole. That's fairly straightforward. That one is a through all. This hole is one of the only ones that's a through to slot. So it only goes through this first top plate of 12.5 millimeter depth. And they have a 3.5 or 3.3 millimeter gap. They also give you the spacing. They don't tell you exactly where or how high this top piece is, and they don't give you this top dimension. They intentionally leave that out. Where you place that will affect the center of mass again. So it's things that you have to watch for. So what I'm going to do is go into SolidWorks and work on recreating this part. The idea is you should be able to recreate each of these kind of pieces very quickly without any additional assistance. No, we're not going to do SolidWorks simulation. Why are you starting a third instance? What is the deal? So SolidWorks is definitely having issues. All right. There we go. I'd go a lot faster if this wasn't slow like claymation today. It's ridiculous. All right. And there we are. So we have our part. There. Yeah. So we have our part. We define our material, which in this case is ASI 1020. And then we look at mass properties and we want to know what is the overall mass of the part. 1127.72 grams. 1127.72 grams exactly. So that is the correct way to make the part and about the most time efficient that I'm familiar with. I would have been able to go significantly faster if I wasn't also screen recording, apparently, because Google Meets is sucking up like all the resources in the universe right now. So I would enter a dimension and 10 seconds later it would actually accept it. So shave probably about 5 minutes off at least just smart dimensioning. And that was about a 20 minute part, give or take. So questions on this? Do you guys think I did it the correct way or not? The grooves inside the shape, yes. The grooves is the tricky part of that. So I'll go back to what that is. I'll just share SolidWorks. There. Yeah, why Google is in like claymation today, I don't understand. Utterly ridiculous. So before I did the cuts for the top and the bottom, what I did for these is on the sketch, I have the two circles. So what I did is I positioned two circles. I set up the center line distances 27 and 27, so 27 square pitch. And then I set 19 millimeters apart for these lines. I moved the lines to make them perpendicular or horizontal. I made them horizontal and therefore perpendicular to the rectangle. Then I moved them and positioned them by dimensions 19 apart and one side 19 divided by 2 to put it in the center. So that's where I set that up to create the C shape. Then I did the math on in the actual extrusion itself, in the extrude cut. I did the math. I did 11 millimeter offset with a 1.5 millimeter depth, giving me the 12.5 from the outside edge to the interior. And actually this one, as a matter of fact, needs to go, because it needs to be 11 millimeter plus 1.5 millimeters, I actually need to switch the direction of that extrusion. And then we'll verify with the measure tool, we'll verify with the evaluate when we redo this one, which I did by an offset from the sketch surface. The math is easier if you extrude to the other side, but I had already done the extrusion because I was just trying to get through the claymation delay here. Literally feels like I'm swimming in molasses and I've only had 1 cup of coffee. So that's how slow it is today. Then I did an offset of the 42 millimeters plus the 11 because it's outside edge to outside edge, the way that they did the dimensioning. 42 plus the 12.5 gives us 54.5 millimeter offset. And in that case, it's 42 to the inside edge. So I need the extrusion cut to come this way toward the edge of the part with a 1.5 millimeter depth. So then I have my 2, and I just want to measure to evaluate the distance between this point and actually it's the inside interior here. So the interior edge is 42 millimeter apart, just like it is in the drawing. So that's why this is exact. This is exactly the recreation of the part. So that's 42 millimeter linear distance between the 2 insides, and that's what they mean by the 42 millimeter interior to interior spacing for the C-clip channels, is what those are, spring clip channels on that part. All right. So does that help clarify how I got to here? The trick and the trap is a lot of students think that the 4.8 distance is from this edge, this corner, to this vertical, and that's where they mess up the part. It is actually along a center line, and it's a center to center distance. It's a center line to edge distance of 4.8 and an edge to edge distance of 9.6, and that's why that's an easy spot to get tripped up on. All right, so questions on this? On our grand clarity scale, let's get a 1 to 10 on where you're at, with 1 being dry dirt, 10 being holy water. All right, so we're seeing some high mid-range numbers. Good. All right, so the next process would be the second part. Let's see. This one's a little trickier. There's a lot to think about on this one. There's an awful lot to think about. But there's a couple ways to present it. Yeah, I don't know why Google is slower than molasses. All right. So this part, how do you create it? If they haven't given you some obvious angle where most of the geometry can really be captured in one sketch, how do you do it? There's going to be front plane advocates. There's going to be right plane advocates. Somebody's probably going to vote left plane because they just woke up. Could do top plane. There's a lot of ways to go about it. So this one, you can sort of make an argument. Sort of. Let's look at another view. So this is a cross-section view. That doesn't really help. So here's a top view. A lot of times they'll give you a top view of what the part looks like. That can be helpful. They'll sometimes give you a side view and an end view. So this one, you at least get some of the geometry. They show you here some of the cutaway. They do a partial cutaway of this shape. And they also do fillets on the interior, which is one of the tricks for the exact mass of that part. And then they give you an end view. So this is right plane view. This is front plane view. This is top view. And they give you the pitch of the set screw holes, 45. They get you depth measurements. So looking at those three, which do you think actually gives you the majority of the geometry? Really, which of those three sketches? Is it top plane? Is it front plane? Or is it right plane? Which one do we think? I'm going to argue for this one. Front plane actually makes more sense. So this is what it would look like to create that part. Okay. It would go a lot faster if SolidWorks wasn't running in Claymation today. And they give us A and B, yeah, 2.125 and 1.25. All right. There's also a tool that they use in this one. They give you a wall and rib thickness. There is a rib tool. I'm not going to use it on this one because it's only sort of helpful. But I'm going to make an argument that you want to start from, in this case, what would be the front plane looking on the side view of this. And that's where we're going to start. I'm going to change what I'm presenting here. Do it. Do the thing. Come on. Keep up, software. Not asking too much. Remember to switch to inch pound second. So it won't be immediately clear, but I'll clarify what I'm doing here. This is a cookie cutter that I'm using to press the geometry I want onto that surface since it's a blank extrusion. It's a simple additive method like a stamp that's removing material. So if I do an extrude cut and I do up to next, up to surface, and I pick this surface, then I have my circle geometry, and I didn't have to work extra hard. I didn't have to be concerned about some of the other nonsense going on. I'm going to do the fillets here, just like I was doing, using the half diameter measurement as the reference point, since they're all symmetrical. Now I need one more reference. Again, that step won't be immediately clear exactly to all of you. To clarify, what I've done there is created an additional piece that goes inside this geometry to avoid the zero thickness conflict that inevitably comes up, so that I can then do a fillet and get it as close as I can. This is one of the reasons why this particular part was dropped. We need to fillet this edge to this face, and that's very hard to do. So we actually need to select essentially this one and do a radius of 0.1. You can get here and it will fix the geometry. I only know that because I've done it before. So it fixes the geometry. You have to go past this to get the zero thickness issue resolved. Then you have the correct part. So the only thing that's missing are the planes. Again, the reason why this particular one was discontinued from the geometry is it creates many issues. So in order to get these, you have to have, you can do a reflection, but you have to do at least one mirror. So this is a 45-degree offset. You have to do a reference. You have to do a first reference, plane one, and you have to do an angle offset of 45 degrees. And it doesn't like an angle offset of 45 degrees. The second reference point needs to be, the second and third reference point need to be through 2 points where you want to be able to do something. So it's at 45 degrees with respect to plane one. It's at 2 reference points vertically so that I can center it. And what I can do now is create the plane, change the size of the plane, and now I have a 45 degree. I can do a essentially like a mid-plane cut here. But what I have to do is line that up with the center line. So on plane 2, I have to select it. I have to add a sketch. And then it needs to be relative to, we're going to have to do another reference actually to be able to use it, called an axis. So stuff that you generally don't have to deal with, but we're going to use this cylinder and we're going to drop an axis through that. Okay. I'm going to change the view so that we are square with respect to the plane. So on this plane with this axis at the height with that as the center line, we can do the sketch that's needed on plane 2 and get this cut the way we need to. So this is 0.136 diameter. Assuming it's actually doing what I tell it to, which it's usually not. And it's at a height of or depth of 0.19. And it has to be something like a midplane with a thickness sufficient that you get all the way through. So now we need to mirror this geometry. Mirror across plane 1, the cut extrude. So then we have our 2 holes at a 45 offset. The other things that we need to tidy up are the fillets that were missed. Okay, so we've got all of our fillets on the inside of the box, and that captures all of the geometry mostly done with a single sketch at the side view. So it is possible. It is also a little bit of a pain. We have to specify the material. And this one is alloy steel. So then we check our mass properties, and they're asking in pounds. 0.48, 0.47 is our answer. All right. So there's a couple ways to go about that. That is really about the most reasonable rather than making 800 sketches, but it requires some critical thinking about the steps involved. So there's a reason why this particular part is gone and ones like it are not on the test, because this is stuff that tripped up a lot of people. And it takes just more time because you have to add more reference geometries and things. So you're not going to have ones that are quite exactly like this on the exam. But the question becomes, is that clear? Is that not clear? Where are we at overall? Using the cookie cutter method is because I wanted to do the extrudes of all of the details first. And then the cookie cutter method works on geometries where you have to do something like a circle in the middle and you can't get there with a fillet, which is the case with this particular example. So what are the questions on that one? Where are we at on the clarity scale? A couple people are mostly following. All right, good. Because we are basically out of time. So that part took significantly longer, and that's why that kind of part is not on the exam anymore. We will be taking that fairly soon, but I wanted you guys to get a chance to understand what's actually going on there. So, all right, I'm going to take a look at a couple other details, and then very shortly we will be taking the exam. I've got to get the next class started, but other than that, you guys have a good weekend.